Good afternoon, everybody. For those of you who don't know, I'm Sarah Delany. I work for NBS. By profession, I'm a building services engineer, and I've been writing specification content for NBS for 18 years now. But this other work stream with classification, I've been involved initially with CPI, the Committee for Construction Project Information, and we started talking about classification or the need to develop the original 1997 version of Uniclass back in 2006. So I've got quite a lot of background in this, and hopefully I can answer most questions. So classification is a means of structuring information, and that makes it easier to find and share information. And we use classification in our everyday life without really knowing that that's what we're doing. If you're going shopping, you know that if you want apples and broccoli, you go to the fruit and vegetable department. If you want a nice piece of meat, you go to the meat counter. If you want a bottle of wine to go with that, then you go to the alcohol aisle. So it's something that helps us define what we want when we want it, in spite of the fact that a lot of supermarkets change their shelves regularly, principally to confuse us, I'm absolutely certain, but there's a basic principle to it. So Uniclass is the classification system which was originally requested for by the UK government to manage information in both construction and asset management. And there were some very clear guidelines of what this classification system should be appropriate for. The first thing was that we were asked to adopt the framework set out in ISO 12006 Part 2. It's not a very detailed standard, this one, but it does put a fairly clear set of requirements, and one of the primary ones of that is that each class of information needs to be in a separate table to make it absolutely clear. The next thing was the government wanted us to make sure that it was applicable to both building and infrastructure. So unlike the original 1997 version where there are separate tables for civil engineering, this classification has to be appropriate for use, because where do you make the difference between the station on a railway line? The station is a building, the railway is a part of the infrastructure. So it doesn't make sense to have separate tables for that because they're joined. And the third really important requirement was that the entire classification had to be appropriate for use throughout the entire life cycle of the of an asset, and has to be able to be used whoever is using generating or using information. And one of the things that's really key about Uniclass is that because it is structured to ISO 12006 Part 2, it does help you to comply with the processes set out in ISO 19650, which requires a classification structured to ISO 12006. Now, since we first started this work back at the end of 2014, and it was published in April 2015, or the first tables were, we've worked with a huge number of organisations to extend, to draw on people's expertise, to improve, amend, correct the tables. We've worked with the Environment Agency, the Metropolitan Police, Highways England, and we're currently also working with the BIM for Rail group and the BIM for Water group, and also the Department for the Environment. So drawing on people's expertise, discussing with them, ensuring that there's a degree of agreement and authority about what we then add into the tables and publish. And for those of you who don't know, we publish the tables 4 times a year, and there is a widget somewhere on the website, although I'm told it's buried right at the bottom, which allows you to ask to be notified whenever there's a new update. When we publish these tables, and these are the current tables that you can download, we always publish with it a list of all the changes, every single change, code by code. And we've recently started producing a changelog, an Excel sheet which has a changelog file, which again summarizes what codes have been deleted, what codes have been added, and where there have been amendments and why there's been amendments, so that you've got as much information as we can help you with. So taking those tables, there is a basic hierarchy, and this reflects the structure set out in the ISO. So complexes are not necessarily large things. They're not defined by size. They are collections of entities. So a private residence can be a complex, and that will be your house, your garden, your tool shed, your greenhouse, the drive, a garage. Each of those is an entity which come together to make the complex. Obviously, with things like universities and hospitals, they're much larger things, but they still are made up of a number of different entities. And these then can all come together. And there are occasions, I suspect, where a complex is actually an entity in itself. There is no hard and fast rule about that. But entities can then be broken down into spaces or location. Now, obviously, location relates particularly to linear entities, where a space is really not a useful definition. So we worked with the ICE in the early days, and this was the way that we've accommodated the fact that location is a really vital part of being able to classify things for linear entities. The activities table is a little bit more flexible in that it can relate to each of these tables. So, for example, with a prison complex, the overarching activity is detention. But once you start looking within the prison, there are entities that are suitable for activities outside of that detention, even though they have that umbrella activity over them, an exercise area, a hospital wing, administration areas. So in that case, then you've got this ability to use activities in many different ways. And then when you come down to the spaces location, there are some spaces, like in a school, where you can have multiple activities in a particular space, like an assembly hall, which obviously appropriate for assemblies, can be used as a canteen at lunch times, can be used for physical education, but also for performance. So again, no hard and fast rules about this. There's no necessarily one-to-one links between these, but they're all there and hopefully cover most of the way that you need to use the table and the codes. Moving to the construction side, you can describe many entities in terms of their very basic parts or elements, and those elements and functions. The functions are the basic services like drainage, lighting, communications. And those elements and functions can be defined in more detail using the systems, which take you into a lot of detail, and the systems are made up of products. So again, a hierarchy. And when it comes to terminology, throughout we've more or less used the terminology in 12006 Part 2, but we've added in location, and also functions was something which the ICE, we work with the ICE to bring in, because their asset managers manage certain functions. The one table which is a little bit out of step is the systems table. When we first started work on this, we had a work results table and a systems table. The work results table we ended up having to drop because there were two classes of information in it, both systems and products, and that didn't match the requirements. So instead of swapping over the titles, we stuck with systems, and that doesn't quite tie up with the definition in ISO 12006 Part 2. So when it comes to using these tables, managing information throughout a project, you have a client, and we have codes for each of the personnel that would be involved, although please let us know if you find ones that we haven't covered. And the client makes a decision that there's a need for a new asset, and whether that's a secondary school complex or whether it's a piece of road. The client then has to set out the brief of what is required, and that can be set out in terms of the activities that are needed for that particular asset. And in this case, I'm looking at a school, and this is a list of some of the activities that need to be accommodated within this new asset. And then here you've got the list of the spaces which allow those activities to take place. And you'll see that with most of them, there's a congruity, good word that, to move from one table to another. So the grouping in the complexes, entities, spaces, location and activity tables are all the same. So as you move from one to the other, you're locked into a specific grouping depending on what particular aspect you're looking at. And then this information comes to the design team, and this can be made up of many different people. I've given here a selection of them, and the architect, a structural engineer, mechanical engineer, an electrical engineer, and a cost consultant. Now, it's actually quite helpful, I think, to use these roles codes for defining things in your responsibility matrix. But it's probably also quite helpful for the cost consultant if they have a series of costs associated with each member of a design or project team. Then it helps the cost consultant to keep the client up to date with the sort of costs that are going to be involved in the design development. And that applies right throughout. So once you get into construction, you've got a similar thing. And it also helps. We've worked with one organisation where they've set up a list of the personnel involved in carrying out refurbishment work and maintenance work, and they have costs alongside them. So when they come to look at a particular job, they can easily download the costs for the particular personnel involved in carrying out that piece of work. So this team then work together on producing the project performance requirements, and this is the list that comes from the project management table, and each of these subgroups is broken down into a number of other listings. So all that information is coordinated and prepared, and that informs then the design development. So once you've started working on a model, you can then attach codes to each of the basic elements of that model to identify the substructure, the walls, doors and windows, roof, floor and stair. And to that code can be attached the performance requirements for each of those particular elements. So you're starting to link information to your model, and that also feeds into the cost management side of things as well. As you then move into the further development of the design, you're starting to add in systems, making specific decisions about exactly what type of foundation you're using. And again, what this does is to help to allow information to be attached to a code linked to a model, which includes costings and specification, as well as the performance requirements and the link to the model. So all of this information is beginning to build up and to be available to anybody who needs to use it. And of course, that's predominantly your construction team. And so what this information is going to allow the constructors to do is to order the appropriate materials, plan the installation, to get the appropriate personnel on the site to carry out the work, and all the tools and equipment. And all of that information can be coded. There's a tools and equipment table, and obviously you've got the products and the products table to give you the materials and that sort of thing. And as the contract moves on, then it's important that the contractor and the subcontractors keep the information up to date with these specific pieces of equipment that are installed, and any alterations to the original design, any amendments to perhaps the performance requirements or that sort of thing, all kept up to date, so that that information can all be passed on to the facilities manager, that they can then draw on what information they need in order to be able to manage the system. And obviously the asset manager has exactly that same role. So you've got your construction team are predominantly information users, but actually they're also information generators. And if you're structuring this information in a standard way, it means that your data can be very consistent. And so whoever needs the information will have certainty, whether they're a designer, constructor, any member of the construction team, the project management team, and that will involve people outside of the organisations as well. By having mappings to other structured information such as NRM and SFG20, it gives you the ability to link design information with cost management and facilities management. There are mappings to NRM in the systems table, and early in the new year we intend publishing alongside BIEG the mappings to SFG20 as well. So that will help with this, using information for the appropriate tasks that you need, but still keeping that link to all the original design performance requirements and the particular plant and equipment as well. So it's also really important that asset managers and facilities managers keep building on that information using their processes, so that they keep a record of what does work, what's efficient, and what doesn't work, so that that can all be fed back into future projects, either development of an existing asset or construction of a new asset. And this is really vital, obviously, to all part of the soft landings part of the process. And of course, the other thing is that a building doesn't exist in isolation. There are many different considerations that need to be borne in mind and to work with. There's going to be utility services provided to any new asset, and although obviously there's probably not much in the way of gas supply to a road or a railway, but these different companies need to have information from you in a way that is helpful and structured. The local authorities need to take account of what the effect is of this new construction is going to be on the surrounding roads. There's obviously construction traffic, deliveries, construction staff. Once the building, this school, is in use, there's going to be the staff traffic and all the parents delivering their children to this, or it could be children arriving by either bus or train. So it's really important that this information is structured in a way that for now and for the future, the information can be brought together and compared, so that for a future project, or to draw on information from a previous project, you've got really solid, consistent information to tell you what the likely effects are going to be. And of course, once you start moving into infrastructure projects, you're crossing all sorts of different barriers and boundaries. The HS2 project, which is hard not to know anything about, that new line crosses so many different assets along its route, whether it's crossing a river, a road, a canal, power lines, gas pipelines, drainage systems. They need to be able to assess the information about that at every single point. If it's organised in a standard way, it makes it so much easier to be sure they've got all the relevant information that they need. You've got exactly the same sort of thing with the tunnel to bypass Stonehenge. I mean, the amount of information around these sites of special scientific interest is huge, and the work involved with getting archaeologists in at the appropriate time is obviously really huge as well. And embankments are a really interesting topic, as I suspect many of you know. In this instance, I've picked out from the Environment Agency website an embankment that's part of a flood defence. But railways have embankments and roads have embankments. They're in many cases a similar construction, but not always. And sometimes they are joint flood defence and railway embankment. So having information which is clear, unambiguous and consistent becomes even more important in this particular instance. And so what you're going to get to help with your interoperability, if you're using a standard classification for structuring all your information, you're going to have the ability to transfer information, not just from one organisation to another, but one piece of software to another. And that's where the work with the IFC and COBE group comes in, to ensure that the way information is structured can be used consistently, whatever the software that you're using. It will give you better ways to compare efficiency. It will give you better ways to compare costs, easier ways to share information relevant to more than one organisation within a sector, but also easier to share information between organisations in different sectors. And so it's hard to imagine why we haven't yet got this standard classification embedded in everything we do, to make the sharing of information so much more consistent and more reliable. And that is over to you.